Okay, this is 6th grade, Engage New York, Module 1, Lesson 15. You need your classwork to go along with the video. Make sure that you have that. It's a synthesis of representations of equivalent ratio collections. That sounds complicated, but don't worry, it's not. A synthesis is just a collection using them all together. So that's what you need to be thinking about when you hear the word synthesis, is putting it all together. Now, so far, we've learned 6 different ways that you can represent equivalent ratios. The first one that we learned is using a tape diagram. Make sure you're writing these down on your paper. Then we learned how to use the description of equivalent ratios. We've also learned how to organize them on a ratio table, a double number line, write an equation, and lastly, we were putting them on a coordinate plane. All of these strategies will help you have a good understanding of different ways to represent equivalent ratios. So we're going to be working with these six representations today. At the end of the morning news segment, the local television station highlighted area pets that needed to be adopted. The station posted a specific website on the screen for viewers to find more information on the pets shown and the adoption process. Make sure you're reading this along with me. The station producer checked the website 2 hours after the end of the broadcast and saw that the website had 24 views. 1 hour after that, the website had 36 views. In exercise number 1, we need to create a table to determine how many views the website probably had 1 hour after the end of the broadcast based on how many views it had 2 and 3 hours after the end of the broadcast. Using this relationship, we'll be able to predict how many views the website will have 4, 5, and 6 hours at the end of the broadcast. Okay, so this time they're telling us to use a table. So that's going to be a ratio table. So when you're doing that, you need to think about what 2 things are we comparing. We're comparing hours after the broadcast, the number of views that the website had. And they told us 2 hours after the broadcast, the website had 24 views. And 1 hour after that, the website had 36 views. Said, based on this relationship, we need to know how many views after 1 hour, and then predict after 4, 5, and 6 hours. Push pause while you complete your ratio table. All right, now you should have recognized that to go from 2 to 1, you need to divide by 2. So 24 divided by 2 will give you 12. You can use this relationship to then calculate 48 views after 4 hours, 60 views after 5 hours, and 72 views after 6 hours at the end of the broadcast. Moving down to exercise 2. What is the constant number C that makes these ratios equivalent? The constant number C is what we use to find the value in the description of equivalent ratios. So if you think back to that rule, we know that the ratio A to B times the constant C will give us a new and equivalent ratio, D. So in this case, our A to B ratio would be 1 to 12. And our new and equivalent ratio would be 2 to 24. What would our constant C be that would prove these ratios are equivalent? 1 times what number equals 2? You should recognize that 1 times 2 is 2, and therefore 12 times 2 is 24. In this relationship, the constant value C is 2. Using an equation, represent the relationship between the number of views, V, the website received, and the number of hours, H, after this morning's news broadcast. So now we're going to be writing an equation. We have to be very careful about that and look at the order that they've given us. So it said the relationship between the number of views and the number of hours. So on your paper, write the ratio for the views to hours. We're down at the very bottom under exercise 2. Okay, so we've got it in a different order here. Here we have 12 views to 1 hour. And you should remember from a couple of days ago how to write the equation. In this case, views comes first in our ratio, so our equation will equal views. Leaving hours to start our equation. All of these equations are multiplication equations. So now we need to find the multiplicative value of this ratio. Push pause until you can find the multiplicative value of this ratio. Okay, you know that to find the multiplicative value of the ratio, you need to write your ratio in fraction form. 12 is first, so 12 goes on top, over 1. 12 over 1 is the same as 12 wholes. So the multiplicative value of this ratio is 12. So then the multiplicative value of our equation is 12. Once you have written an equation, you need to go ahead and plug in some numbers that you already know to make sure that it works. So you can pick any number up here. I'll choose 3. So I'm going to plug in 3 for the number of hours. 3 times 12 equals 3 times 2 is 6. 3 times 1 is 3. So 3 hours should be 36 views, and that does match up. So I know this equation is true. Turn the page. Exercise 3 says use the table that you created in exercise 1, our ratio table, to identify sets of ordered pairs that can be graphed. We practiced doing this yesterday, and if you want to look back at your ratio table, you can do your ordered pairs there. I'm just going to make another column right here. So ordered pairs. Now, we have to remember about ordered pairs. They're always in parentheses. Our coordinates are separated by a comma, and it's always x, then y. X comes first in the alphabet, X is first in our ordered pairs. So our number of hours are going to be our X coordinates, and our number of views will be the Y coordinate. So for this ordered pair would be 1, 12. Okay, push pause until you've created an ordered pair for each of these. Okay, you should have 2 to 24, 3 to 36, 4 to 48, each of them should be in parentheses and separated by a comma. They stay in the same order. Before we're able to plot these on our coordinate plane, we need to remember the 4 steps that we learned yesterday and make sure that we're following each of those. Step 1 was to label your axes. Boys and girls, I already know which axis is the x-axis and the y-axis. So when I want you to label them, that is not what I want you to tell me. I already know this is the x-axis and this is the y-axis. Now, on your paper, the coordinate plane that you have doesn't show these coordinates. So you don't need to break what you have into 4 parts. You're only seeing this quadrant. So that dark bold line with the arrow on the top, that is your y-axis, and then along the bottom with the arrow, that is your x-axis. So we now need to label what they represent. So looking at our x-coordinates, they're telling us the number of hours. So underneath our x-axis, we need to label it hours. Then looking at our y-coordinate, these numbers are telling us the number of views. So we're going to label our y-axis views. Once you've labeled both of those, you need to create a title for your coordinate plane. What is this coordinate plane going to tell us? What is the purpose of this information? So for this coordinate plane, I'm going to title it the number of views for each hour after the broadcast. That explains what the number of hours are and why we would need to know this information. So that's something that you would probably write at the top of your coordinate plane. Okay, now I have a title for my coordinate plane. I need to create a scale. The scale is the value for each space, and I'm going to have two, one for the x-axis and one for the y-axis. Looking at our x-coordinates, I'm going to see what we're counting by here. It wouldn't make sense for me to be counting by 100s or even 10s. These coordinates are all counting by 1, so for the x-axis, your scale should be 1. Remember that you're not numbering the space. It's the value of the space. So by the time they get to that first line, it'll be 1 hour after the broadcast. So label the lines along your x-axis counting by 1s. Okay, now I need to create the scale for my y-axis. You have to go back and look at your y-coordinates. Now, this is going up to 72. It wouldn't make any sense for me to count by 1s. There's going to be a lot of empty space. So I need to pick a scale that makes sense for the numbers with the views. All of these are multiples of 12. So it would make sense for me to use a scale of 12 on the y-axis. So on each line, you're going to label it counting by 12s. Now, there's a lot of lines on there. You don't need to number all the way up. Just go a little bit past what you have. Once you've labeled your scale on both your x and y axis, it's time for you to plot the points. Okay, when you're plotting your points, you always need to start by hovering your pencil over the origin. Our x coordinate tells us to move left or right. So with a coordinate of 1, I'm going to move over to the right and just hover my pencil above the 1. Now it's time for me to move along the y-axis. So our y-coordinate is 12. I'm going to follow that line by 1 all the way up till it intersects the line for 12 and mark it with a point. I'm then going to do that for my next ordered pair. Starting back at the origin, I'm going to move over to the 2 and then follow that line up until it intersects with the line for 24 and mark it with a point. Push pause until you have plotted all of the coordinates that we've been given. Once you have those on your paper, you'll see that they make a straight diagonal line. That's an indication to you that this is going at a steady rate and that these represent equivalent ratios. Okay, now that we've completed exercise number 4, turn it over to number 5. It says, predict how many views the website will have after 12 hours. So far we have worked with up to 6 hours after the broadcast. Now we need to determine how many views there will be 12 hours after the broadcast. Use 2 representations to justify your answer. So here we have 6 different strategies that you can use. You need to pick 2, any 2 that you like, to prove to me the number of views the website will have 12 hours after the broadcast. Push pause until you have that done. Okay, let's go ahead and check to see what you were able to come up with. You may have chosen to use a tape diagram, and that would be okay.